Hi, this is Irv Shapiro with the MakeWithTech channel. I get a lot of requests to review Ender 3 style printers. They're basically printers with a print volume of about 235 by 235 by 250. Many of them are very similar. Maybe they're priced a little different. Maybe they have some different add-on features such as a filament out detector. I turned down the majority of those requests. When the folks from Fokoos approached me to review their printer, and they sent me this printer for free in order for me to review it, I found the characteristics were a bit different. It's a direct extruder printer. It has an all-metal hot end. It has a bootloader, so you could load the version of Marlin you wanted onto the printer right away. So it had some different characteristics. But one of the challenges with all of these printers is sometimes they're a little tricky to assemble. They're more like an advanced IKEA assembly than a typical appliance. Then I got this box from Fokoos. This looks like an appliance. This looks like something you take out of the box and you can use immediately. And in fact, it's probably the closest to that standard that I've seen in a consumer-priced, lower-end 3D printer. So the question is, how do they do that? Well, they do that using a very unique construction. Let me show you. This printer actually folds. So it comes folded flat, wrapped with some big ceramic wrap around it. You lift the gantry up, you put 4 screws in, you attach the filament holder to the top, that wasn't on it, and you plug in 2 cables. It's a 10-minute assembly. So in this review, I'm going to look at the other characteristics of this printer. Does it print well? Is the quality good? Is it easy to work with? What type of support do you have in the slicer they provide or in more generic slicers? So stay tuned and let's learn something together. Now, before I assemble this printer, unfold it, put in the 4 screws, let me show you what comes in the box. You do get a mini reel of filament. I used this filament for a number of prints and they came out quite well. In the box itself, you get pretty standard things. You get a quick start guide and a user's guide. Now, for an old guy like me, the type size in these manuals is tiny. So the same manuals are available, perhaps updated, on the SD card that comes in the kit. So I would use those particular guides. In addition, just to give a shout out right away, there's an extremely both active and useful Facebook group for this printer. And I'll share a link below in the description and you'll see the link here on the screen. So before you start assembling and using this printer, I would go to that Facebook group and just browse around a bit. Let's see what else is in here. Well, one thing that's interesting is you have spare cables. The cables on this printer, you can see here, if I turn this around, are ribbon cables. And it allows for a very clean setup. If you compare this to an Ender 3 where there are cables all over the place, this is a very clean setup, which also makes this printer potentially much easier to move around. So you get some spare cables. You get a print scraper, a lifter. I didn't find this very useful. I didn't find the edge sharp enough. I personally like using a single edge razor blade in a mounted case for that purpose. You get a generic diagonal slicer. You get some tools and some bolts. Now, the tools that are provided are almost complete for what you need. You'll see here I have 2 wrenches. They give you 1. The second one actually came from a Creality kit. And I'll explain a little later in the video why you need 2, or why I needed 2. You do receive an SD card and an SD card adapter, so you can look at the instructions. And once again, I recommend you do that. You use the version on this SD card, and you get a couple spare nozzles. So all in all, it's a pretty simple kit. And the reason is there's very little assembly. Okay, so now I'm going to assemble together this printer, which once again consists of taking the screws out for the gantry, lifting the gantry up, this bracket, as I indicated before, I had added on earlier, and then there are 4 screws. They're actually bolts. It's very, very easy to get them into place. So let's get one into place and finger tighten it just a little bit. Okay, we're all set. Now, if you hadn't done it already, you would put this bracket on top that goes on top with 2 extrusion nuts and 2 bolts. There are cables, one here and another one over here, that come disconnected. You have to connect those in. Now, these are flat cables, and let me show you with one of the spare cables. They do not have connectors on the end. They're just actually flat cables. So you have to slide them in carefully. Because they're already mounted, glued to the gantry, they can only go in one way. There should be no twists in these cables. So it's a very, very easy assembly. The Z-axes on this printer are dual Z-axes. That means they're 2-stepper motors. They move in parallel. That has an advantage and a disadvantage. We'll see in a minute. The print quality, layer to layer, is so good the layer lines seem to disappear in many of the prints that I made. But it means you should never turn either of these manually, because these have to be kept in perfect alignment. In fact, when you lower the gantry all the way to the bottom, it's not a bad idea to take a ruler and make sure it's completely straight across. If it's not, you'd have to adjust these couplers here to straighten it out. But mine came perfect from the factory. Another thing that's very unusual about this printer is this sensor here. Normally, the way the printer knows when the print head is at the bottom position is there's a micro switch here. Those micro switches can bend and get out of adjustment over time, which is one of the reasons you're often retuning your print bed more often than you'd like. On this printer, that Z-axis sensor is a proximity sensor. It actually senses this metal coming down to this sensor. So it should be very precise and very, very consistent. Everything that leads to the fact that layer to layer, this is an outstanding printer, the best in its class I've seen. The mechanism for the print head is a typical extrusion with wheels. Perhaps you can see it better from this direction. So you have 2 wheels here, another wheel here. This extrusion, and in fact the extrusions for the Y-axis going back and forth, in my opinion, are a little bit light. In particular, because this is a direct extruder printer. There's no Bowden tube here. But the extruder itself and the motors seem relatively compact. The print quality on the XY direction, Y from this extrusion wheels and X from this extrusion wheels, is good. I'd say it's average in the class. To get the best print quality possible, you want to ensure that this mechanism is not loose here, that it moves smoothly. If these wheels are too tight, it will not move smoothly. If these wheels are too loose, it will move around, and that will cause more ghosting and other artifacts on your print. So how do you adjust that? As you can see, this is very easy to move this printer around. If you look behind these wheels, on the wheel down here, there's something called an eccentric nut. I'll show you a close-up picture of that. When you take and you put your wrench on that eccentric nut, as you turn it, it will pull the wheel down or push the wheel up. So you adjust this eccentric nut right here until this rides smoothly. On the base of the printer, on the print bed, there are 4 wheels. 2 of them are fixed, 2 have eccentric nuts. You adjust those wheels on the eccentric nuts in order to move them in or out, so the print bed moves back and forth as smoothly as possible. Now, the reason I needed an extra wrench was on my printer, when I was adjusting the print bed eccentric nut down here, the post was turning. So I had to put a wrench on the nut on the top and then another wrench on the nut on the bottom to adjust the eccentric nut. Now, when I look at this print bed, it has a little bit more movement than I would like. You can perhaps hear that a little bit. Now, it didn't seem to cause a lot of difficulty, but I believe it does lead to just a bit of ghosting. Now, let's look at this screen together. The sections that you have here are printing, which is to print off the SD card. Then on the other end, you have tool. Tool gives you all of the abilities to set up the printer for printing. So you can preheat the hot end. You can extrude some filament to make sure it's extruding properly. You can home the printer. We also have the ability to individually move any of these. So I'm going to, let's say, move the Z-axis up a little bit. Now, one of the things you'll notice is how quiet this printer is. It's quiet because it has TMC 2208 stepper drivers. Those are the chips that control these motors that move the components, and they're a higher quality, a more advanced chip that move them very smoothly. The control board in this printer is an MKS Robin Nano control board. Also a very well-known, respected control board, which is why you're able to load standard Marlin 2 software on this printer. And you're able to load it by just putting it on the SD card because there's a boot loader built into this printer. Now, one of the first things you're going to have to do with this printer is level the print bed. Now, you're not actually leveling the print bed, or maybe you are, but you're ensuring the height between the nozzle and the print bed is uniform in the 4 corners of the print bed and the middle. And the way you do that is you go to leveling, and you're going to start with what's called 0.1, but you should have a sheet of paper. I like to use Post-it notes. I think they're about the right size. And you go and you press 0.1. And then you put the Post-it note underneath where the print head is going to go to. There you go. And then when you move the Post-it note, you want there to be some friction, but you don't want to tear the paper and you don't want it to be hard to move. Then there are knobs, and I'll show you close-ups of these, under the print bed. Those knobs are used to raise and lower the print bed. Because there's a spring between the print bed and the knob, when you tighten the knob, it will pull the bed down. So righty-tighty, lefty-loosey. When you loosen the knob, turn it to the left, the print bed will go up. That will make it closer to the nozzle. So our paper is too hard to pull out, so we're going to tighten this until we can move it and there's friction, and we can feel the friction here, but not too much. Now, one step I skipped that you should really do. You should really heat up the print bed before you make this adjustment. So you go to the first place, you get it so the friction is just about right. Then you select 0.2. 0.2. Then you go to 0.3. Then you go to 0.4. Now, if your print head is too far from the print bed, your prints won't stick. If it's too close, they're actually going to stick too well, and it's going to be very hard to get your prints off. Let's once again move our Z up a little bit because we're going to load our filament, and you never want the nozzle right at the print surface when you're loading your filament. That's under the next entry called Filament. So if we go to Filament here, there's an option for load, and it will say heating up the nozzle. And it will not let us continue until the nozzle is heated up. While the nozzle is heating up, you want to make sure your filament is cut on an angle and placed on the reel. I'm not sure it matters which side it's on. I put it on the side so there's a straight line down. Then you want to straighten your filament out. I find that's a very important feature. And then you can stick it in the hole here on the side of the printer. Now you're going to have to press this in quite hard in order for it to go in. And it will help a lot if you cut it on an angle. And you should see some filament begin to come out the bottom. Now I was using gold filament before, so you'll instantly see some gold here. If you're switching colors and the color hasn't changed yet, then you can go back and just do it again. And you'll extrude some more filament here. So that's how simple it is to load filament on this printer. Now, some of the additional areas on this printer, there's a section called Settings. Normally, you will not have to change these, but these give you the ability to fine-tune this printer, to fine-tune the temperature control, the PID variables, to fine-tune extrusion, the step variables. These are all available from the front panel. Now, that's beyond an introductory review, but it's very, very impressive that a printer of this class exposes that level of detail. Now, let's show you how you print from this printer. You go back to the main screen, you select Print, then you can navigate the directory structure with the up and down arrows. And what you'll see here that's very interesting is you'll see pictures. Those pictures are produced by the MKS Wi-Fi plugin for Cura. You can load that on the version of Cura that comes with this printer, which is for Windows machines, or you can load the very latest version of Cura, add that plugin in, and then you'll see pictures of what you're selecting. So let me select one of these prints and hit confirm. You'll now see the picture come up on the screen. You can adjust the fan, the temperature, the Z offset that's called baby steps on the screen, and the speed while the print is printing. Once again, features you don't always see in this class. Now, a couple hints. First, anytime you fold this printer and unfold it, you should recheck the bed leveling, because it is possible that things won't tighten up in exactly the same places. Likewise, in general, if you're removing and replacing the print bed, which just holds on with clips, you should do the same thing. You should check the bed leveling. Now, the print bed itself is a sheet of glass with a wonderful textured surface on it that holds prints very well. If anything, it holds them too well. I found that if I have my nozzle a bit too low, it will hold the prints too well. I tried to solve that problem by using a bit of magic goo, which is a bed adhesive that I like using on here, and that worked for prints that didn't have very large bottom surfaces, but a print like this still held too well. And the way I got the prints off that was easiest was to simply put it in the freezer. Take the print bed with the print, put it in the freezer for 5 minutes, and they'll come right off, and the bottom surface will be perfect. So just a good trick to know about. Okay, let's look at print quality now. So the first print I printed was the owl that came on the SD card. You'd expect that to print well, and it's a beautiful, almost perfect print, except for a little bit of stringing across the top. So then I thought I'd kick it up and print a much more complex print. This is the Kickstarter Calibration print, and it checks a number of different things. It checks for bridging. The bridging on this printer was very good. It checks for overhangs. This overhang printed quite well. At the top of this print, the spires, the posts, are smaller than your nozzle size. Anytime you have a feature that's about your nozzle size or smaller, it's very hard for your printer to extrude just the right amount of filament, which leads to stringing. And a perfectly tuned printer can print this without stringing, but what's more important is on the base. These are about 1.5 millimeter features, and there's no stringing at all, which is consistent with what I saw with some other prints. So I printed 2 of these at the same time. These are supposed to be taco holders. These are for very small tacos. I would print these a little bigger in the future. The prints came out beautifully with this silk gold filament that I used, and there was no stringing at all on these prints. Then I printed a much more difficult print that also tests tolerances. It tests the ability for these flexi objects to print in place. This printed perfectly. So with that in mind, let's go back to this Kickstarter test. So the other thing it tests is whether you can print in place features with tight tolerances. And what you have here are a series of pins that will fall out if they don't fuse to the size. So only the smallest one, which was at a 0.2 millimeter tolerance fused. The 0.3 and above all worked properly. So from the factory, without any additional tuning, this printer printed those very well. Finally, you have these circles here. I'm going to take a caliper here. Let's take a look at those. The bottom one is supposed to be exactly 25 millimeters. In this case, it's 24.82. That's pretty darn good. But let's see, is it round? So we'll measure it in the other direction, and it's 24.79. So the accuracy, the precision, the extrusion of this printer in this price range is very, very good. Finally, if you look at the front of this print, there are a bunch of very fine lines. You won't be able to see them here on the camera, but they're used to detect ghosting. And along the y-axis, moving in this direction, there is a bit of ghosting, and I saw that, and I continue to see that in other prints. So because you have dual Z rods, the precision layer to layer is very good, which is why you really can't see the layer lines at all in this print. But because going back and forth, you have wheels on those extrusions, and there's a little plane here, you get a little bit of ghosting in that direction. So if we look at this print, it's a beautiful print, and up and down, because these were printed flat, so this is the layer lines here, it's perfect. Side to side, there's a little bit of ghosting. And that was a 15-hour print, printed seamlessly. This was a 10-hour print, also quite beautiful. And if you look carefully here, I'm trying to see if I can detect any ghosting. I don't detect any ghosting here at all on this print. Overall, this is a beautiful print. This is the print that was stuck to the print surface I put in the freezer. And also the bottom, because you're printing on this glass, is quite beautiful. So I would rate this printer as better than average in this class. I'd also rate an Ender 3 version 2 from Creality as better than average in this class. In this case, the Z-axis quality is even better than the Ender. In my test prints, the Y ghosting is a little more pronounced than the Ender 3 Model 2. Now, what about slicing for this printer? Well, it ships with a version of Cura that works on Windows that's been rebranded by Fokoos. But it's basically a relatively recent version of Cura. I tried digging under the covers and figuring out, it looks like it's probably 4.6, 4.7, 4.8, somewhere in that range, relatively recent. If you want to use the latest version of Cura, or you want to use Cura on a non-Windows machine, you can't use the slicer that came with the printer. You have to install your own version of Cura and set it up. So let me reset my workspace here, and I'm going to show you how to do that. Okay, to get started, just head over to the Ultimaker website. That's ultimaker.com, or Google Cura and select software, and go to the page on downloading Cura and then download the version for your operating system. I've already done that. Install it the way you normally would on Windows or a Mac or Linux. And now I'm going to open up Cura. And I have Cura version 4.11 for this demo, but this should work equally well with any standard version of Cura. So the first thing I'm going to do is define a new printer. Unfortunately, there's no capability in Cura for importing a printer. It has to either be built in or you have to copy files under the covers. We're just going to use an existing printer as our starting point. So I'm going to go here and select Manage Printers, select Add. Down here, I'm going to select Creality and the Ender 3. But I'm going to rename it to Fokoos Odin -5, and I'll leave Creality Ender 3 in parentheses so I know how I started. And I'm going to click Add. Now, hopefully at some point in the future, Fokoos will work with Ultimaker, or really the Cura open source community, to get their printer right in. Now we need to make some minor changes. The print size is all the same, but the print head offsets are different. Now, if you go to the Fokoos manual, page 16, you'll get the new offsets. So it should be 26 minus, should be minus 20, and then minus 10. And then, now you'll see that changed. I'll show you why in a second. And then this should be 10. And this should be 10. And the gantry height is 10. Now, you'll notice that changed back to minus 10 once we got the below numbers in. So you have to set the print head offsets. We have to do one more thing. This standard Ender 3 profile prints a purge line, a sort of a warm-up line at the very edge, you can see it here, of your print bed. It's a little too far over for my taste, and if you get your print surface not exactly on the edge, you'll actually be printing off the print bed. So we're going to go down here to the start code and make a change. But it's hard to change here because the box is so small, so I'll show you a trick. So we're going to click on Next, that will save it. Then we're going to go back to Machine Settings, and now you'll see the box is bigger. And see here where it says X0, we're going to change that to X2. So we're going to move this line into 2 millimeters. We have to change 4 of those. The first 2 are the first purge line, then there's a second one right along it. So they're going to print, instead of at 0.1 and 0.4, they're going to print at 2.1 and 2.4. And then we're going to click on Closed. And now Close. Now, I could go ahead and slice the model and it would sort of work. But there's one very important thing that you should change. This is a direct extruder printer. The Ender 3 is a Bowden style printer. So the number of retraction you need is different. So you should create a new profile. So you should open up Settings and click on the hamburger bar over here and click on All. So that'll make sure that you can see all the settings. Then I want to go down to Travel. I'm going to make this box a little bigger here. And instead of retraction of 5 millimeters, I'm going to change it to 1 millimeter. Now I'm going to leave the retraction speed alone, but that change is going to be very important. You'll see this item down here goes orange, so we have to change that basically to match the amount of retraction up above. Now I don't want that to go away when I exit Cura, so I'm going to go right up here and I'm going to say create a profile from these current settings. And I'm going to call this MakeWithTech Fokoos. So now I have a new set of settings with the retraction set differently. Now, if you want a finer tuned profile, there are a bunch of profiles that are listed in the Facebook page for Fokoos. I'd recommend you go to one of those profiles to get a finer tuned profile that you can work with. Now there's one more thing we need to do. We need to get the pictures on the screen. If I go and I slice a model now, there won't be a picture. It'll just be a solid box with an F in the middle. So how do we get the picture? Well, we need to go to the marketplace and click on plugins. Now, this takes like 30, 40, 50 seconds, maybe a little longer to pull these back. It's not really fast. I'm not sure why, but we have to wait for that. And then we have to scroll down until you see MKS Wi-Fi plugin. Now, this is a plugin for the boards made by MKS. The Robin Nano board that's in this computer, the control board, is made by MKS. We're going to install this. We're going to agree to the conditions. We're going to quit Cura. Then we will restart Cura to load that plugin. Now we have to do one more important step. We have to go back to our printer, go to Manage Printers, and you'll see an option here called MKS Wi-Fi plugin. We have to click on that. We have to enable the plugin. Leave the Wi-Fi support section unenabled because there is no Wi-Fi in this printer. Go to Preview Settings and enable screenshots and set it to default, and then close it. And then close again. Now let's slice a model. It could be any model. Go ahead and slice it. And you'll notice here there's a new option that says Save as TFT file. That option will save the sliced G-code with a binary header, which is the picture for that screen. Now, if instead of using the Marketplace edition, you go to GitHub and you get the MKS Wi-Fi code from there and you load that into your printer, you will not have the Save as TFT option. It will automatically include the TFT header if you have the plugin enabled the way I showed you. Okay, folks, let's wrap up what we've learned. This is a very easy to assemble printer. Perhaps the easiest in this price range, but it is $50 to $100 more than a Creality Ender 3. What do you get for that extra money? In addition to an easy to assemble printer that you can fold down to move, you get a direct extruder, and it's a very good direct extruder. The quality of these prints, the precision, the tolerances were very, very good. You get a very responsive touchscreen that exposes a complete set of Marlin parameters. You get a printer with a bootloader, which the Ender 3 version 2 also has, that allows you to upgrade easily to Marlin 2.0, the latest edition, and there's instructions in the Facebook group for doing that. You get dual Z-axes, which you don't have on the Ender 3. You get a proximity-based Z-axis sensor, which you don't have on the Ender 3. And you get a print surface that never failed to adhere to any print I threw at it. So who should buy this? Well, if you can afford the extra $50 to $100, you don't want to have to assemble it, these extra features are well worth it in my opinion. So I can comfortably recommend this printer as the first printer for a lot of people new to 3D printing. Well, folks, I hope you enjoyed this video. If you did, please give me a thumbs up, recommend this to your friends, share this video with other people. Feel free to go to the Facebook group from Fokoos and leave comments. I'll leave that link down below. There are also links in the description where you can buy this printer. Those are affiliate links, so they help support the channel. And then if you want to show your prints and discuss things in another place in addition to the Fokoos forum, you can go to forum.makewithtech.com. Thanks again, and let's continue to learn things together.